1 minute. Hello.
Yes, sir.
Everyone getting this?
Yes, sir.
Yes, sir.
Okay. So, last class we have discussed about your basically impulse and momentum. But this class basically will go to your work energy theorem. Work energy theorem. You can go to your work energy theorem. Who can say what is work? Hello. Hello. Am I audible?
Yes, sir.
Okay, okay. After is your work and kinetic energy. But your unit 9, work and kinetic energy. All of you listen in your +2, you know what the work. Who can say when work is possible? Hello?
Sir, when some
Hello?
force applied to an object and some displacement is done. Distance.
Okay. Okay. So, your work done basically depends upon your applied force. Work will be done when you apply the force, and by the application of force if the body is displaced. So, but you can apply the force that is your constant force or variable force. According to this, you will find out the work or you will do the work. For work, body must be displaced under the application of force. But that work done we can calculate in two ways. One method is when force is constant, then work done you can get F dot S, Fs cos theta. Are you know or not?
Yes, sir.
Yes. So that formula you know, work done due to your applied force, but force is constant, then work will be done. That formula is basically your Fs cos theta. Fs cos theta. If you apply the variable force, your applied force time to time changes, then we must do that integration or area under force and displacement graph. This is your work done by constant force. Work done by constant force on an object that undergoes displacement d by the application of a work done by a constant force F on an object that undergoes displacement d is defined as Fd if he applied force along the direction of displacement. That means force and displacement in same direction. If in having certain angle between the applied force and displacement, then formula will be F cos theta and a displacement. So work done equal to F dot displacement. Everyone clear? Hello?
Yes, sir.
Yes, this is your formula. And this F dot S by F d cos theta basically the work done depends upon the angle between your applied force and a displacement. This cos theta value ranging from -1 to +1. Your cos 180 value is -1, cos 90 value 0, cos 0 value 0. If your applied force direction, everyone see here, your applied force direction same as the displacement, then theta 0, then cos 0 1. Your work done will be maximum and positive value. But theta is 90 degree, you are applying force, but body displaced in any direction. If you applied force 90 degree to it, then no work will be done. Here given your figure, you see 9.8, 9.5. The work done on an object by force applied perpendicular to the displacement. The work done will be 0 because angle between displacement and the force is what? 90 degree. Everyone clear? Hello?
Yes, sir. Clear.
Yes.
Yes, sir.
So, suppose you apply the force, that force is opposite to the direction of displacement. Then theta will be 180 degree. Your force and displacement direction are reverse, that opposite direction. Then work done will be negative or minimum, that is minus FD, because cos 180 minus 1. Can you give one example of this negative work done? Hello? Hello?
Sir, take it
Anyone?
out ଉପରକୁ ପଠଉଛି ସେ ତଳକୁ ଆସୁଛି gravitational force
Yes,
negative
yes,
କାମ
and
କରୁଛି
also gravity, work done due to gravity. And also another, you listen, your friction. When your displacement in east, then friction will be direction of west. So friction always opposite to the direction of the displacement. So work done due to friction always negative. Understood my point? Hello? Hello?
Yes, sir. Understood.
Yes, sir.
Work done due to constant force basically depends upon angle between them. You apply the force. If properly you apply, work will be done 100%. If you don't apply the properly, work done will be not 100%. It is less, and also negative work is possible if your displacement opposite to the direction of the force. So this thing already you know in plus 2 level. And if your work done, basically force is variable. Force is variable. Then how to find out the work? This is the work done for constant force. Then basically work done for variable force. How to find out? Work done of an object due to here given place to your positive work done and negative work done. Positive work will be done when angle between them applied force and displacement will be less than 90 degree. Then work done positive. If the angle between them, the applied force and the displacement is less than greater than 90 degree, work done will be negative. Here given and explained with certain examples. Now we'll go. This is your positive and negative work done solution. You can get directly. That depends upon angle. If angle 0, this is maximum positive work done. Angle 180 degree, that is negative or minimum work done. But here given certain force, displacement and work done. In one direction, one dimensional application of force on x direction, then displacement will be along x. Then the work done will be your x direction. But in two dimension, in a plane you apply force x and y direction, then displacement will be both direction, work done will be in both direction. Like this 3 dimension. So these are the formulas. But here given some examples and a description. Your maximum force, no force, till force you are applying, no work, till force you are applying, no work is done. If it is 90 degree, here given many examples are there. Understood my point? Hello?
Yes, sir.
Yes.
Yes,
These
sir.
examples you remember, but opposite direction, displacement and the force, then work done is the friction. Here given friction, work done against the force of friction, or viscosity, viscous force acting on a fluid. Okay. Hello.
Yes, sir.
Hello.
Audible, clear. Yes, sir. Audible.
Audible. Very good. Thank you. And this is your work done due to apply your basically your constant force. If a variable force, then we never find out work done by that formula. We will go to integration method, by calculus method, and the graphical method. So here given work energy theorem and kinetic energy. Work energy theorem and kinetic energy. Everyone see your anybody, your force equal to mass into acceleration, net force equal mass into acceleration according to Newton's second law. Suppose the body initially at rest, then speed for the, what is its speed for constant acceleration? Now v square minus u square equal to 2ad by 2as displacement, here we are taking d. So your ad equal to v square by 2. Everyone clear? Your formula is the, your d equal to v square minus u square, your v square minus u square equal to 2ad. Your initial velocity u is 0 means v square equal to 2ad. Then ad equal v square by 2. Everyone clear? Hello?
Yes, sir.
Yes. Now you comes to your work done equal to force into displacement. Force is ma, displacement is d. Then for ad you put half v square. For ad here you put half v square. So your work done equal to half mv square. Everyone clear? Hello?
Yes, sir.
So your work done is the kinetic energy. Here we have verified, and the energy coming from the, that your basically that is your energized or active. That's why it is a 80 plus energized. That is your work. The best translated as a ability to do work. The meaning is, don't worry for this. Then you come for your energy. Energy is the capacity of doing, capacity of a body to do work, or ability of the body to do work. It is always measured by the work the body is capable to doing. So kinetic energy is half mv square. All of you listen. If initial velocity not 0, initial velocity u, final velocity v, displacement d, then v square equal u square plus 2ad. So your v square, your ad equal to what? Half a v square minus u square or not? Hello? Hello?
Yes, sir.
Yes, sir.
Yes. So your work done will be, this work done equal to change in kinetic energy. Change in kinetic energy. Final kinetic energy minus initial kinetic energy. This is your work energy theorem. Work done equal to change in kinetic energy. Your final kinetic energy minus initial kinetic energy. This is very, very important. This is very, very important. Work done here. Work done, work energy theorem. Work done equal to final kinetic energy minus initial kinetic energy. So all of you remember this formula. This is very, very important. Always coming problem on this formula. Am I audible to everyone?
Yes, sir.
You are clear about this work energy theorem?
Yes,
Yes,
sir.
sir.
Yes, very good. Very, very good. So this work done formula problem will come here written. Don't forget, or this forget this. The work energy theorem is only a accounting concept. Can and your accountant explain why a business makes or your or loss money. So this is one of the story type. Everyone like this you read. Then your concept will be more clear about the work energy theorem. This is your work energy theorem. In work energy theorem, given many questions are there. Your work done is equal to final kinetic energy minus initial kinetic energy. But all data will give, only you find the final velocity here. Mass given, initial velocity given, force given, displacement given, find the final velocity. You apply this formula. Half mv square, this is your formula, half mvf square minus half mvi square, initial velocity, equal to f into s. So you put this half mvi square, you take that side, then you will get this formula. Are you getting this formula or not? Hello?
Yes, sir. Getting, sir.
Yes. Then you put all these values, you will get significant result, you will get. Then this is your work energy theorem. In work energy theorem, many examples are given. Basically, depends on final initial velocity. Accordingly, you can get the work done. Then your this work energy theorem, another question here. Many questions are given. If you solve these questions, your concept will be more clear. Then your work done by variable force. Whatever I said you, the work done you apply, you can apply constant force on any object continuously for 2 hours. Hello, hello,
No, sir.
No, sir.
no, not possible. So we must know how to find the work done due to variable force. Work done due to variable force, basically we will do the integration method. Very small part we are taking, getting the work, then total part say A to B, we have to do the integration, displacement D1 to D2. So it is a range for this, by this method, finally we will get a formula, this is your work done equal to force into displacement, but ranging displacement D1 to D2. So displacement given, suppose this 0 to 5 meter, then your variable force given, and you integrate it, then take the limit, you will get the value. So this formula is very important for your variable force. But another important point, if you know your graph given your displacement and force, the area under this displacement force, you can get the area under displacement force graph, you measure the work done. Everyone clear? How to get the work done by the variable force? Only integration method. Your displacement d1 to d2 f dx integration. Everyone clear?
Yes,
Hello?
sir.
Yes, very good. You remember this formula. And work done by spring.
और एक बार समझा दें इंटीग्रेशन
All
मेथड.
of you listen again. Your work done, suppose time to time your applied force is changes. That means force changes according to your position. Suppose now you are positioned in origin to 1 meter, whatever force, if you go 2 meter, force changes, 3 meter, force changes. That means force is a function of a position. For this type, you do the integration of f of very small dx displacement, work done is f dx. But if total displacement d1 to d2, d1 to d2 range is given in there, so you integrate the limit d1 to d2 for small work done f dx. For total work done, you have to do integration and put the limit. Okay, everyone clear? Hello,
यस सर.
hello,
Yes, sir.
hello, hello, hello.
यस सर.
Yes, sir.
क्लियर सर.
Yes, sir.
So work done by spring force. Already you know how much work will be done by the compression or expansion of a spring. Your spring force is always you remember the formula. Your half or minus k by 2 x2 square minus x1 square, because here you see the work done formula f dx, but position changing from x1 to x2, and here it is coming if it is spring force is minus kx or not. Already told you previously, spring force is what? Minus kx. Everyone know or not?
Yes, sir.
Yes, very good. So you do the integration, your minus half minus k, your k x dx, k is constant, will come outside, your x dx is x square by 2, but limit x1 to x2. So minus k by 2, x2 square minus x1 square. This is the work done due to compression or elongation of the spring. Spring work done always negative, because it is elongation or compression, work done by the opposing force. Work done by the opposing force, spring force. Spring opposes to your applied force. Okay, displace your spring force always opposite to the direction of displacement of the spring. If you want to compress the spring force is opposite to it. But you elongate the spring, then spring force also opposes to it. So work done due to opposing force always negative. Everyone clear? Hello.
Yes, sir.
Hello. Yes, very good. Very good, everyone. So you remember this formula, very important, this spring force. then you solve this type of question in your spring force. Work done by force, work done by force of gravity. Gravity or work done is the work done equal to your work done equal to loss or gain of a potential energy. Work done by gravity. So force here mg, force here mg. Work done by gravitational force. Then your in place of force you put, suppose your you put you give certain force on a body, you throw a body in upward direction, this is z axis. Z axis means in x direction, y direction force will be zero. No work will be done because nobody is displaced along y or the x, only in the upward. Upward is z axis. Z axis means your work done will be F equal to mg. When you are putting upward any body in the upward direction, your mg acting in the downward. So it is minus mg. Everyone clear? Hello?
Yes, sir.
Yes.
Yes, sir.
So you do the integration, you will get minus mg into change in the position along z direction. Change in height along z direction. बुझिएला ना? Everyone clear? Hello?
Yes, sir.
Then this is your work done by a gravitational force. Already you know this is the gravitational force between Earth and anybody. This is my minus g me your gravity and gravitation, Newton's law of gravitation. Already we have studied previously. So this is your work done by gravitational force formula you are getting. Position from Ra to Rb. Then normally F value here you put. Then you do the integration. Then you will get your work done due to gravitational force is this. This is also you remember only integration you do the total work done due to variable force. Because when you apply and you put or you throw any object, when it is coming down, its speed increases because gravitational force increases due to gravity. Everyone clear? Hello?
Yes, sir.
Hello?
Yes, sir. Clear.
Okay. So work done by variable force. You see here. Work done by variable force. One example given. Then your power. Power is what? The power is your rate of doing work. For unit time, how much work you are doing. That is important. In whole day you will do very small work. In whole day and in very small time you do big work. That power is very, very important. Electric power is important. Your power is important. How much work you are doing, that is not important. For unit time, how much work you have to do. That is called power. That's why power is your basically we are measuring always electric power. How much watt? This watt bulb, this watt power required for the fan, this watt power required for your rising the water or raise the water from your oil. We are using the that is your motor. Various power of the motor. Motor is not power is very very important. Everyone clear? Hello. Hello.
Yes,
Yes,
sir.
sir.
So power equal to rate of doing work. Total work done by total time taken. Total work done by total time taken. This is called power. So instantaneous power also you can find out dW by dt instantaneous. So your dW is F dr, then F dot dr by dt equal to velocity. So power is the dot product of force and velocity. So dot product of force and velocity is a scalar. Dot product of two vector is a scalar. Okay, everyone clear? Hello. Hello.
Yes, sir.
Yes, very good. There's some problems given and here summarized. You go through it and getting any doubt you can ask me in your that non-official group. And this is the terminal questions. Very very easy questions. You have to solve it. And any doubt you take the photo and send in that group. If any friend can solve, otherwise I will solve. No problem for this. Everyone clear? Hello.
Yes, sir.
Hello.
Yes, sir. Yes.
Yes, very good. Then your unit 10 is the potential energy and the conservation of energy. Potential energy and the conservation of energy. Anyone can send your attendance report. Hello. Hello. Hello.
Sir. Yes, sir.
Very good. Very good. You can send. Okay. Now you comes to your potential energy and conservation of energy. So your potential energy and the conservation of energy or your mechanical energy, basically you have the kinetic and potential energy. So we have to show here basically uh, there is inherent in nature a hidden harmony that reflects itself in your mind under the image of a simple mathematical law. That is your you can remember. Then we will go to your potential energy and your conservation. Yes. Okay, you have the various types of forces. Your contact force, non-contact force, already you know. So what the conservative force? Who can say? Hello, hello, hello.
Yes, sir. In conservative force, the total energy is constant.
Actually, conservative force work done due to this does not depends upon path followed. Only depends upon initial and final position. Only depends upon initial and final position. Not depend upon path followed. Okay. Your conservative force not depends upon path followed, but work done due to conservative force in a closed path will be zero. Zero or not? Hello?
0, sir.
Hello?
Yes, sir. Zero.
Zero.
Zero,
Your
zero.
gravitational force is conservative. But your electrostatic force is conservative. But basically your that is friction or your viscosity, these are non-conservative forces. Non-conservative forces. Understood my point? Hello?
Yes, sir.
Hello? So work done by the spring force is conservative in nature. But work done by gravitational force is also conservative in nature. Only depends upon initial and final position x1 and x2. And here also z1 and z2. Your gravitational force, because gravitational means you are putting upward and downward direction, falling the body or rising the body. That is z direction. That's why here we are taking z2 and z1. Here we are taking x2, x1. So work done due to conservative force only depends upon final position and initial position. Similarly, work done by force of gravity on an object that undergoes initial position your RA, final position RB. Only the work done depends on initial final position, that is called your conservative force. So in your conservative force, you are getting these formulas. Your conservative force, you are getting these formulas. So you have written the definition of conservative force. A force is conservative when work done by this force on a moving particle is independent of the path of the particle between particle initial and final positions. It is the same for any path you are coming from one point to another point. Everyone clear? Hello? Hello?
Yes, sir.
Yes, yes, sir.
Very good. Very good. If any path you can go, any path. Suppose this is your initial point. This is your initial point. This is your final point. So you go to any path from initial to final point. Any path, then it will be your work done will be any path. This path or in this path, the work done will be same. Any path you can go, so the work done will be same. Everyone clear? Hello? Okay. So, like this, you can do the work and work done at any path for your conservative force is the same. Everyone clear? Hello?
Yes, sir.
Hello? Yes, very good. So, your this is your conservative force. And another definition of conservative force, if it is a closed path, work done is zero. Already told you. You remember this. And here examples are given. Work done due to conservative force. Many examples are given. Your work done due to conservative forces. Here given. Work done due to conservative force zero. Here verified. You can do it. So, some non-conservative forces means already told you the work done depends upon path followed. The work done depends upon path followed. And work done due to a closed path, not zero. It is total work done we have to take. This is called your non-conservative. Everyone clear? Hello?
Yes, sir.
Yes, very good. So, another is your potential energy. Potential energy, everybody knows. The potential energy depends upon configuration and position of the object or body. Your configuration and position of the object or the body that measure the potential energy. That measure the potential energy. If your body configuration change, you are standing. If you sit, your potential energy will change. So, potential energy depends upon your configuration and your position. So, how to find the potential energy? Your work done by conservative force on a particle as it moves from one point to another depends only on the starting and finishing position and not on the path between them. So, conservative force means your total work done A to B F dot dr. So, RA to RB. So, position your position vector of A is RA, position vector of B is RB. So, your function of RB and this will come function of RA. Whatever value will come. So, this work done is nothing but the potential energy. RB minus plus RA. Your final potential energy plus initial potential energy. Negative of your work done is very, very important. You remember your work done due to, I am saying you, basically, all of you listen, your so you can apply the conservative, you remember this formula. The formula is very, very important. This formula is very important. You remember this formula is very, very important. This formula. If you take one negative sign common here, your work done equal to, but negative of work done equal to your change in potential energy. You remember, negative of work done equal change in potential energy. This is the negative of work done. This is the negative of work done. Is it visible to all? Hello?
Yes, sir. Visual.
It is your negative of work done. Negative of work done. This is your negative of work done equal change in potential energy. Change in potential energy means final potential energy minus initial potential energy is equal to negative of work done due to conservative force. Very important. Change in potential energy equal to negative of work done due to conservative force. Change in potential energy final minus initial potential energy equal to negative of work done due to conservative force. Everyone clear? Hello? Hello? This formula 10.1b is most essential formula. Change in potential energy equal to negative of work done due to conservative force. So potential energy here, change in potential energy, your UB minus UA, final initial potential energy equal negative of here written. The change in potential energy of a particle between any two positions RA and RB is defined as the negative of work done by your conservative force. in moving the particle from RA to RB. Everyone clear? Hello? Hello?
Yes,
Hello?
sir.
Very good. Very good. You are very good. So, your potential energy, some problems given, you can solve it. These are some questions and problems. Your potential energy of the force of gravity. Here, you can find out already gravitational force, you know, Gm1 m2 by r. This is rb minus ra. So, formula is the negative of work done. Your potential energy by change in the potential energy equal to negative of work done. So, minus of Gm1 m2 by this. Everyone clear? Hello?
Yes, sir.
Yes, very good. Your potential energy function for spring force. They are given for spring force, your potential energy you can get, then potential energy for your spring force. Your explicitly you can find out the potential energy by change in potential energy equal to your negative of work done due to conservative force. This formula very important. Always problem will come. And your potential energy and stability. This is also another parameter. So, potential energy and its relation with the force to help us determine the stability of an object or the system. Stability. That means what relation between potential energy and your force. So, force equal to negative of rate of change of potential energy. Your force equal to all of you see this is your integration. If you differentiate both sides, this integration will be removed, then it will here will come your d del u by del x, but du by dx equal minus fx. So fx equal minus du by dx or not? Hello? Hello? In this formula 10.2 you differentiate both sides. When you differentiate both sides of this 10.2 formula, then you will get 10.3. Everyone clear? Hello? Hello?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
Yes,
Yes,
very
sir.
good. So this du by dx is known as a potential gradient or potential energy gradient. Any quantity differentiate with respect to position, that is called gradient of that quantity. So you remember this formula f of x equal minus d by dx. This is called stability. This your for spring you can write your potential for spring is half kx square. Then your f equal to minus kx. So this is the spring force given by Hooke's law. So used for computing the force from potential energy function. It also helps us determine the stability of a system. Okay. So for an object or system moving under conservative force, the condition for equilibrium we can find out here. So equilibrium means your net force is zero. If you put force equal 0, du by dx is 0. So your equation 10.4 satisfies some point x naught. We now state condition for stable and neutral equilibrium. So you remember, dear students, this is du by dx equal 0. That means no net force act on the system. That is called equilibrium position. You have the three types of equilibrium: stable equilibrium, unstable equilibrium, and your neutral equilibrium. The condition for stable equilibrium क्या है? Your suppose if at x equal x naught, your d square u double derivative of u u is greater than 0, the second order derivative u is positive, the object or the system is in stable equilibrium. Very important point you remember. If he at x equal to x naught, your d square u by dx square, double derivative of your potential energy, if greater than 0, then the body is in stable equilibrium. If the double derivative less than 0, the body is unstable equilibrium. If the double derivative of potential energy equal 0, we must look at higher derivative. If all derivative vanishes, so u is constant in a region about x naught, the object is the neutral stability or neutral equilibrium. Everyone clear? You remember these 3 points. When stable equilibrium, when unstable equilibrium, when is your neutral equilibrium. Everyone clear? Hello?
Yes, sir.
Yes, sir.
Hello? Yes, very good. You note these points, you check, equation will give, and you do the double derivative. If you are getting positive, this is your stable equilibrium, negative, unstable equilibrium, zero, neutral equilibrium. Everyone clear? Here given your stable equilibrium BPA. Once you disturb it, again it will come back to this position. And unstable, once you disturb it, never come back. And once you disturb, it will get the same position. One position to another position, it is neutral. No change anything. Everyone clear? Hello? Hello?
Yes, sir.
Yes, very good. You see this stable, unstable. Then conservation of mechanical energy means total initial mechanical energy equal to total final mechanical energy. Kinetic energy plus potential energy initially equal to kinetic plus potential energy finally. So here initial kinetic energy, this formula everyone see. This is your initial, everyone see 10.6. This formula very important. Your initial kinetic energy plus initial potential energy equal to final kinetic energy plus final potential energy. Everyone clear? Hello? 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 Hello?
Yes, sir.
Yes, very good. This is your conservation of mechanical energy. And this total energy is constant initial energy equal final energy. Sum of kinetic, this is your EF and EI. EF means your final kinetic plus final potential. EI means initial kinetic plus initial potential. So kinetic and potential energy in the mechanical system is conserved. Kinetic and potential energy in mechanical system is conserved. Here given some examples. Everyone you see here velocity is V, initial velocity is V naught, final velocity Vf, height is this, then how much velocity, final velocity. That's work done. Change in the kinetic, change in the potential, final you see. This is your initial kinetic energy, half m V naught square. Initial potential energy half m g h is 100. Your final kinetic energy half m Vf square. Final potential energy half mg h is 65. Here at this position, this is the initial position. Everyone, all of you see initial position. You get here kinetic plus potential. Then this is your final position. You get the kinetic plus potential. Given can get potential, velocity can get kinetic. So then you will get the Vf, this unknown value. Everyone clear? Here written. Here written. Everyone clear? Hello.
Yes, sir.
Very good. Very good. So conservation of mechanical energy, another question here given. You solve all these questions. Very good questions. Then velocity of escape, moon, law of conservation of energy. Law of conservation of energy. So total energy in this universe constant. Only energy transfer from one form to another. Your light energy converted into heat, or heat energy converted into electricity. But total energy in this universe constant, only transfer from one form to another. You go to any level, total energy remains constant. Force of elastic deformation, whatever, your total energy in this universe constant. So finally you will get that formula again. This formula. Your kinetic energy of body B plus potential energy of body B or position B minus kinetic energy plus potential energy of equal to work done. So this is your work energy theorem. Total change in energy, total change in mechanical energy equal to work done. Your final mechanical energy minus initial mechanical energy, total change in mechanical energy that is equal to work done. Here written EB. EB means final total mechanical energy. EA means initial total mechanical energy. This is called change in mechanical energy equal to work done. This is called your mechanical work energy theorem. Everyone clear? Hello?
Clear, sir.
Hello? Yes.
Clear, sir.
A law of conservation of energy. The change in the total energy of an isolated system is zero if all forms of energy are taken into account. Your total energy mechanical plus other form of energy equals zero. So this means that your energy is constant because isolated system के लिए total change in energy zero, change in energy zero, not energy zero, change in energy zero, final energy equal initial energy. So change in energy of an isolated system is zero. No change of energy in an isolated system, so energy remains constant. Everyone clear? The total energy of an isolated system is conserved if all forms of energy are taken into account. Everyone clear? Hello?
Yes, sir.
Hello?
Sir, so black body radiation energy.
Hello? हाँ बोल हेलो
सर जो ब्लैक बॉडी रेडिएशन होता है
हाँ ब्लैक बॉडी तो
उसमें
जो
थोड़ा एनर्जी
क्वांटम मैकेनिक्स हाँ दिस इज हीट एनर्जी विल बी रेडिएट when anybody is heated anybody you heat some energy will release that is called radiation black body you heat that black body radiation some energy rate of energy radiation that depends on temperature. If you heat it, then energy will release. That is the black body radiation. That is in the form of photon. That is the basic of quantum mechanics. Okay, black body radiation means your when you heat any object, any body, any object, then it will be radiate certain heat. That is called radiation. Then black body radiation is also same thing happen. Black body will not anything. It will not anything. Everything will absorb. Nothing will reflect. That's why it will be black. So you heat it, whatever absorb, then it will radiate. Understood? Hello?
yes sir
Hello? Hello?
yes sir understood
Very good. So these are the problems you do. Your problem solving strategy here written. You remember these steps. Accordingly, you solve the problems. And here given some important problems are there. Non-conservative force involves your basically here solving the problem given conservative non-conservative forces and here summarize the things. This is your basically this work energy theorem by force equal to negative of potential energy and here terminal questions given. Many questions given. You very important if you able to do all the questions then that means you are understanding the chapter then you do very well in your examination. Understood? Hello, are you solving these questions or not? Hello, hello.
Yes, sir. Solving.
Yes, very good. Everyone solve and very poor present because initially it was 19 now 12 so people students are not interested but still those have interest they are joining no problem but if he 2 or 4 students will join I will take it but I am saying you frequently any problem you write in that group any question any doubt I will clear it because it is online mode.
Sir, please share the link. Sir, please share the link of the groups.
Okay. So actually this is in your virtual mode or online mode. If it is live classes is good, but live classes के लिए you actually this time is not suitable. Evening time is not a good internet. I am doing outside of my home. Outside means corridor, but in corridor there is no board and this live class is not possible. But it is your maximum 4 classes will give you tomorrow another class. Tomorrow you will get another class most probably. Then after this, if you feel any doubt, I will clear. No problem. Yeah. This official class may not be attended, but non-officially I will do for you. Any doubt or anything? Understood my point? Hello?
Yes,
Hello?
sir.
Yes, sir.
Okay. So
Yes, sir.
Sir, please share
you
group link.
have hello. Dear,
Yes, sir.
बोलो हाल हाँ
सर
हेलो
व्हाट्सएप का इनवाइट
सर व्हाट्सएप ग्रुप का लिंक चाहिए सर.
WhatsApp group. अच्छा, you say you which generated this group and WhatsApp is they have to join you. You say your phone number to him or her. Actually, I have not generated. Your students, your friends generated, your classmates. I don't know. Only they have added to me. Hello.
Yes, sir.
Hello. Hello. Anyone can respond his or her question. How they will be the member of this group, this forum. But everyone help those are already in that group. They can help you. Please help them. Hello. Hello.
Sir, I have written my phone number and requested them to add.
Yes, very good.
Okay, okay.
Thank you. So you see, everyone, actually in your BPHCT-131, you have the 4 blocks. 4 blocks. If your block 1 is purely mathematical, your vector and differential equation, that you know these equations, but the basic concept of mechanics, Newton's law, work, and this part is your work. Then your rotational motion and many particle system will start tomorrow. Then next week you will continue the rest of the parts, and everyone go through that rotational motion and many particle systems. Your unit 11 kinematics of angular motion, just like your V you take here omega, angular velocity, angular displacement, angular acceleration. Okay, and the dynamics of rotational motion is the torque. Dynamics of linear motion is force. Here we have to take the torque. Motion under central force. Also we have to study your dynamic of any particle system. Conservation law for many particle system. Everyone go through this. It is available in your IGNO site. You download all these 4 blocks, and for coming class tomorrow, everyone go through this rotational motion and many particle system. Then come. Okay. Hello. Hello.
सर इग्नो साइट रे बुक डाउनलोड होन
You loudly you say.
सर इग्नो साइट रो बुक डाउनलोड करथुल पीडीएफ डाउनलोड होन
Already I have downloaded. I may send you tomorrow or today night 9 o'clock. I will send all the one I have sent in your group. Another 3 I will send. Already I have downloaded today all the blocks. Okay, because
थैंक यू सर
if you keep it in a folder, if you have a laptop or desktop, and you go through it and study it and solve the question, feel any doubt, you can take help of me. Okay, no problem for that. Any type of problem regarding this study, regarding this physics, I will help you. Don't hesitate to ask any question or anything regarding this your physics. Okay, in this pandemic situation, I will help you definitely, whatever doubt you have. Understood my point?
यस सर
Hello. Yes, everyone,
Yes,
this
sir.
is your syllabus. This is your syllabus. This. Anyone can take a screenshot and this screenshot can share in that group. Other student will be aware about the syllabus. Hello, hello,
Sir, sir, block 4.
hello.
Sir, block
Yes,
4
sir.
last.
Huh? Loudly, loudly. Hello, dear student. Hello, hello, hello.
Yes, sir.
Huh? You take a screenshot of this and share in that group. Taken? Anyone can taken? Hello,
Yes, sir.
hello. Yes,
Yes, sir.
very
Yes,
good.
sir. हो गया sir.
Very, very good. Very good. Very good. And so your basically this is very easy. This part is very easy. It is not difficult, but you can easily also do because it is basics of physics in plus two level. What was here only that, not the new. Okay, you can do it. No problem. And any doubt you can ask. Then after this you will get new things. Everyone clear? Hello.
Yes, sir.
Okay. Anything can ask anyone. Hello.
No, sir.
Hello. Nothing.
No, 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 sir. No.
Udit, you are only doing this course or any job?
नहीं sir. कर रहा हूँ. Engineering कर रहा हूँ.
Engineering.
Yes, sir. AME.
Acha, very good. Pratik,
Yes, sir.
okay. You are doing any job or
No, sir. I am
hello?
uh,
Hello.
हाँ हेलो सर. हाँ सर. सर सर नहीं सर, कुछ जॉब नहीं कर रहा हूँ.
Acha, ठीक. Okay, very good. All are very good, and you motivate to your friends. They will join more and more tomorrow. Okay, then you will get the more classes in next week. If students are not joined, so they will not allot the class. This is the problem. If more students join, then they will again reschedule, and you will get the classes. Then you will discuss and run this. Otherwise, if students will not join, they will not give the classes. So you inform to your friends or your classmates taken admission with you. They have to join here. Understood my point? Hello.
Yes, sir.
Yes, sir. Yes, sir.
Yes. Yes. Any question? Any doubt?
सर हमारा फर्स्ट ईयर सेमेस्टर एग्जाम कब?
Actually, you asked to the number already. There you to the coordinator sir or your regional center. They will say about the uh, examination. Okay.
Yes, sir.
Any
So,
question?
sir, subject कैसे
Any
change
other
हो?
question? Subject you can change. How to change?
Yes, sir. Yes, sir.
Okay, you contact to this coordinator sir and regional director office. Everything is possible. No problem. Contact number in the website and already given you that number. You can do it.
Thank you, sir.
Hello.
सर
Okay.
में कॉल किया था, वो जीमेल दिया,
Loudly,
response नहीं
loudly,
आया।
loudly.
सर कांटेक्ट नंबर को कॉल किया था,
हाँ,
जीमेल
कॉल
पे भी
कर लो।
मैसेज, जीमेल पे भी
कॉन्टैक्ट
मैसेज।
नंबर में डायरेक्ट नंबर में कांटेक्ट करो, अच्छा होगा। ईमेल कोई चेक करता है नहीं करता है, लेकिन पता चलता है कि नहीं, लेकिन यू हैव टू कांटेक्ट बाय दैट नंबर, देन अकॉर्डिंग टू हिज हर एडवाइस यू। ओके
ओके सर, ओके सर।
ओके ओके, थैंक यू ऑल। Now I
Thank you,
will
sir.
stop it, end the meeting. Thank you everyone, thank you all.
Thank you,
Okay,
sir.
Thank you, sir.
very good. Okay.